Welcome back. As you know, I am Eli, the computer guy, and in today's class, we're going to be talking about DNS, which stands for Domain Name System, or maybe Domain Name Service, or maybe Domain Name Server. I don't know. It's kind of one of those things. It is weird as an old timer as I try to actually teach you folks classes. There are so many of these terms that we technology professionals use, and many times we kind of forget what they actually stand for, to be honest with you. It's DNS. It's DNS. What does it stand for? It stands for something. It stands for something. That's not important. What's important is what it does. And so what DNS does for you in a network environment is it resolves fully qualified domain names to TCP/IP for IP addresses, right? So when you want to go to a server on your network, you do not want to have to remember the IP address of that particular server. You know, the mail server is 192.168.1.10, your Active Directory server is 192.168.1.11, you know, your file server is .12, the whole nine yards. And you know, if you have DHCP going on, and so you're dynamically assigning IP addresses, can be a real disaster if you have to try to remember all of those IP addresses. Wouldn't it be nice to have a human readable name that you can just remember? File-server, or mail-server, or server, something like that. How do I connect to Active Directory? Go to server and, you know, do whatever else, right? It makes life a hell of a lot easier. When you get onto the internet and you start going to websites such as CNN.com or FoxNews.com, not getting in the middle of this darn argument, right? Again, if you had to remember all of the individual IP addresses for every single website that you wanted to go to, it would be a bit of a disaster. It's amazing in the modern world. I am very jealous of the kids that are growing up now because they never have to remember phone numbers. When I was a kid, you had to memorize everybody's phone number. It was ridiculous, right? It was pretty difficult, and it was a pain in the butt to sit there and to remember, you know, 10 digits for all of your different friends, your parents, everybody else, right? That's kind of difficult. What's kind of cool now is you can go to your phone, you can just plug in somebody's name, hit the call button, and you just call them, right? That's a hell of a lot easier, right? Going to CNN.com is a hell of a lot easier for people to do than remembering, you know, 253.29.1.15 or something like that, right? So having a domain name, having a human readable name just makes life easy. When we start talking about DNS today too, one of the things I want you to really be thinking about is all of the layers of resolution that occur whenever we're dealing with a network, right? So whenever you have computers on a local area network and they are connected to a switch, remember a switch is a layer 2 device on the OSI model, the data link layer, and switches don't know what the hell an IP address is, for the most part, right? They deal with MAC addresses. So when you're dealing with layer 3 networking, where you're actually dealing with IP addresses, that's where you have something called ARP, Address Resolution Protocol. Address Resolution Protocol resolves MAC addresses to IP addresses, right? So it actually matches that in the computer. So now when we're going to like CNN.com, we're going to resolve a fully qualified domain name to an IP address. We're then going to go through the IP network to get to that IP address, and then when we actually connect to the server on the CNN's local area network, there's going to be ARP resolution that occurs. That's going to resolve the IP address to a MAC address so that you can actually get to the server. So it's an important thing to understand when you start dealing with networking, right? We've got layers upon layers upon layers upon layers of resolution and communication and all kinds of things going on, and so that's one of the reasons understanding the OSI model is so valuable for you, right? When I did that class on the OSI model and tried to explain to you how you use the 7 layers of the OSI model to try to narrow down where the actual problem is, I think as we continue on in this networking series, you see, to get one computer to communicate with another computer, there's a hell of a lot of stuff going on to make that occur, and there are a hell of a lot of things that can actually break. So it's just kind of one of those those. Another little, just, talking about the OSI model and so why it's important. So whenever we deal with DNS, all we're really dealing with DNS is we're simply resolving fully qualified domain names, so human readable names, CNN.com, FoxNews.com, server, whatever else. We are resolving those to IP addresses. So let's first talk about how local DNS resolution works, right? So when we talk about DNS, the DNS that you use in your local area network is going to look a lot like the DNS that you use up on the internet. But as with all these things, it's very similar, but also very different at the same time. So let's just talk about the local area network first, right? So you have your computer here. It is connected to a switch. You have some IP address scheme, 192.168.1.x, right? Your computer is 192.168. 8.1. Let's say 55, and you have a file server on your network that you have named, very creatively, file server, and its IP address is 192.168.1.2, let's say, right? And so this is the file server, and so let's say you want to connect to a network share on that file server, in order to be able to access, files or folders or that type of thing. So basically what's going to happen when you go and you try to connect to file server is within whatever configuration screen you're using, you will plug in the name file server. The first thing that is going to happen is that your computer is going to look at a text file on your computer. This is actually installed on your computer, called the hosts file. So the hosts file is a very simple text file that simply resolves fully qualified domain names to IP addresses. You don't see a lot of this in the modern world. This can be used for security purposes, that type of thing. This is kind of one of those, kind of sort of, it's a holdover that's been around, for something that's existed for about 50 years. But basically, if we go up here and we take a look at this, this is essentially what a hosts file looks like. So you can go in there, and basically what you see here is that you have an IP address, and then you have a fully qualified domain name, right? So if you had a file server in here, basically your computer would come to this host file, it would find the record for file server, it would match it to the TCP/IP address that you have, and then from that you would then be able to go, and using TCP/IP you would be able to go to the IP address that is in the host file. If the resolution isn't in the host file, which it normally actually isn't, then what your computer is going to do is it's going to go to the primary DNS server that is already set up within its configuration. So if we go up here and we take a look at this screen, so this is a screen from Windows. Basically shows you what your IP configurations are. You get your IP address, your subnet mask, your default gateway. The default gateway is the router that will get you out of your network. And then under this, you'll have your primary DNS server and your secondary DNS server. That's the proper term for it. Of course, Microsoft screws with things, so this says preferred and alternate, but normally we say primary or secondary DNS server. Essentially with this, what this is your computer, once it goes to the host file, it will then go to your primary DNS server. This primary DNS server, it will ask and say, hey, do you have an IP address for this fully qualified domain name? If it does, it will return the IP address that it has. If it doesn't, if it can't resolve for some reason, then it will go to the secondary DNS server, and it'll say, hey, do you have an IP address for this particular domain, fully qualified domain name? If it does, it will resolve. If it doesn't, it will fail out. And that is basically how DNS works on your local area network. Why you have a primary DNS server and a secondary DNS server generally is because somebody unplugs your primary DNS server every once in a while, right? Again, one of the things you have to be thinking about is whenever you build out your network, one of the things you want to have is redundancy for every darn thing you can have redundancy for. And so basically one of the big things here with the primary and the secondary DNS server is that if one DNS server is down for any particular reason, the other DNS server can take over. The DNS server resolution can be very important on a local area network because most of of the time, almost most of the time, you're not going to hard code static IP addresses into configurations, right? So when you share a folder over the network, people are going to connect using a DNS name. Even within code, you may have proprietary code that you create. They're not going to put in a static IP address into that code. They are going to put in a fully qualified domain name, and DNS will just figure out, basically what the IP address is. If for some reason your primary and secondary DNS servers are down, or DNS does not resolve on your network, essentially, more or less, your entire network fails. This happened in the real world with Facebook. So Facebook, this gets a little complicated, but basically Facebook screwed up what was called their BGP configurations, or something called a Border Gateway Protocol. This is a routing protocol so that routers can communicate with each other in order to be able to route packets, over their network. So somebody did something very stupid and screwed up their BGP configurations. Well, when they screwed up the BGP configurations, basically it shut down a lot of their network. And one of the parts of the network it shut down was actually their DNS resolution. And the problem then was everything else failed after that, because essentially BGP shut the DNS servers off the network. None of Facebook's servers could then resolve DNS names to IP addresses. They could no longer resolve, so all the software and the servers and everything else started to fail out, and it was a complete mess. So this is just one of those things to be thinking about whenever you're setting up your network, especially a business class and enterprise class network. Always make sure you have that primary and a secondary DNS server at the minimum, because, again, even DNS servers get unplugged. Even DNS servers, the power supply fails. Again, one of the things you really have to think about in the world being a technology professional, sometimes it's not the OSI model stuff. Sometimes failures are not these really complicated, sophisticated things. Sometimes, the fan that cools the CPU on the server just fails. The server then overheats and the server crashes. Pretty easy fix, honestly. Just go in there, slap in a new fan. But if everything on your network is relying on DNS, and your DNS server fails for any reason, and there is not a secondary DNS server there, you can run into a lot of problems. So basically, this is all it looks like when we talk about local DNS resolution. So if you have your local area network, basically, you're going to have your computer. It's going to go to the host file. If it doesn't find an IP address in the host file, it will go to the primary DNS server. Then it'll go to the secondary DNS server, basically to resolve that fully qualified domain name to an IP address, and then it will be able to go to that particular IP address. One of the big things here too, one of the issues that you can run into is if a computer doesn't announce itself to the DNS server, right? So you have a DNS server down here, and basically the DNS server is usually connected to the DHCP server. Normally, right? So if you're dealing with the Microsoft world and you have an Active Directory server, generally your Active Directory server will do Active Directory, and it will do DHCP, and it will do DNS. That's in the Microsoft world. If you're just at your home, or you're at a small business, basically you'll normally have your SOHO router, your small office home office router. This will have a router built into it. It'll have a switch built into it. It'll actually have an access point built into it. When clients connect to your router, it will have a DHCP, Dynamic Host Configuration Protocol. This is what gives you your IP addresses, and it will have DNS. And so basically what happens is when your computer basically gets on the network, it's going to ask for an IP address. And when it asks for an IP address, it's going to say, hey, I'm computer 2. My name is computer 2. And so what happens at this point is that your DHCP server gives computer 2 an IP address, and within the DNS configurations, it then matches the name computer 2 to whatever IP address that it just gave you. One of the issues you can have when you're doing troubleshooting routines is sometimes if you connect a computer to your network, if the network isn't configured to do this auto grabbing of the host name and associating with an IP address, one of the problems that you can have is that basically the DNS server doesn't know the name of your computer, therefore it can't resolve the IP address. Again, you may have this in the Microsoft world. So when we talk about Active Directory, again, this is one of those things. In another class, we'll talk about Active Directory, but go with me here, right? So Active Directory is essentially a security service in the Microsoft world. And so this is what gives you permissions to resources on the network. It's a security thing, right? So one of the problems that you can run into is, let's say you have a Linux machine. So you have a Linux computer, like say some file server that you put onto the network. Linux is not connected into the Active Directory infrastructure. It may or may not be able to pull a DHCP address, and DNS, for whatever reason, may not actually grab the name of the particular Linux server. So you may put the Linux server on the network, but you may not be able to resolve the fully qualified domain name to an IP address simply because DNS server refuses to automatically add this name to its table. This is just one of those things, probably higher level than you're going to be dealing with right now, but it is something to keep in mind, right? If you plug a computer into the network and for some reason you can't resolve its host name, its fully qualified domain name to an IP address, it's most likely something within DNS. For whatever reason, DNS is not grabbing that computer's host name, fully qualified domain name, and so therefore it's not resolving. Okay, so this is the simple name resolution on a simple local area network. Now let's talk about how name resolution works on the internet. So instead of trying to go to file server, now you're trying to go to CNN.com, right? So you have your little computer here, you plug into your computer, hey, I want to go to CNN.com, and you need to get the IP address of CNN.com so your traffic can actually be routed to CNN.com. So let's say CNN.com is 204.66.4.1. I don't know, let's just say that's their IP address, and you need to try to find out what that IP address is. So the first thing your computer is going to do is it is going to go to its host file, that text file that you have on your computer, and it's going to try to see if it can resolve CNN.com here to an IP address that you already have configured within the host file. Again, most likely, unless you're doing something custom, it's not actually going to resolve to the host file. So then past that, what's going to happen is your computer is then going to go to the primary and the secondary DNS servers that are on your network, and it's going to ask those DNS servers, do you have the IP address for CNN.com? At this point, let's just say they don't. There is caching that happens within this whole DNS resolution routine. So basically, if one client on the network needs the IP address for CNN.com, most likely the DNS server will actually cache that information. But let's just say this is a new request, and this particular DNS server does not have the IP address for CNN.com. Well, within the DNS server, a DNS server is a computer like all the other computers, and so the DNS server is actually going to have its own primary and secondary DNS server configured within the DNS server. So basically, your computer goes to the DNS server, says, hey, do you have the IP address for this fully qualified domain name? The DNS server that you're communicating with, that's on the local area network, so this is still on the LAN, says, no, I do not have the IP address. So it's then going to go to the DNS server that's configured within its network configurations that are most likely going to be the ISP's DNS server, right? So whenever you go out and you get a modem from your ISP, they're going to give you some configuration information, and some of that configuration information is what is going to be the DNS server for the ISP. So basically, right, the local server is then going to go to the cloud. It is then going to go to the ISP's DNS server, and it's going to say, hey, do you have the IP address for CNN.com? Again, let's just say it doesn't. It probably does. It probably actually has this cached away in its little database system, but let's say this is a new thing, and so it doesn't. So from there, what the ISP's DNS server is going to do is it's going to do a forwarding. Is going to forward the DNS request to the root servers, so the root DNS servers. There are theoretically 13 root DNS servers, and these are the DNS servers that are the highest level DNS servers in the entire galaxy. There are no DNS servers above these particular 13 DNS servers. Of course, This is the real world of technology, and when I say 13 DNS servers, I mean back in the day it was probably actually 13 physical boxes. At this point, there's like 13 clusters with redundancy and all kinds of other stuff going on. Let's just say your ISP's DNS is going to communicate with the root DNS infrastructure, let's just say, and basically request like we need to know what the IP address is for CNN.com. At this point, the root servers are then going to direct your ISP's DNS to the top level domain servers, right? So the top level domains is when you see .com, when you see .edu, when you see .org, these are top level domains, and they actually have DNS servers specifically for those top level domains. And so since you have CNN.com, the root servers are going to tell the ISP's DNS server, you need to go to the .com TLD, top level domain DNS servers, to try to get the information, the IP address for CNN.com. Once you then get routed from the root down to the top level domain servers, basically the top level domain servers are then going to have the settings for what are called authoritative name servers. These are basically the authoritative name servers, or essentially the DNS servers for whoever you purchased or CNN purchased your domain name from, right? So when you go to GoDaddy.com and you buy, EliTheComputerGuy.com or SiliconDojo.com or CNN.com, when you go and you buy that domain name from GoDaddy, one of the things that GoDaddy is going to do is it's going to put an entry into their authoritative name servers stating, okay, EliTheComputerGuy.com. Basically, this is whatever IP address you've set up within your configurations for the DNS configurations, right? So I build my own server, I get an internet IP address, I then tell GoDaddy I want EliTheComputerGuy.com to point to 206.17.76.1. Right? And so what's going to happen here then when you're trying to go to CNN.com, so you're going to go up to the root servers, server infrastructure. They're going to point you down to the .com TLD, top level domain infrastructure. The top level domain infrastructure is then going to point you to the authoritative name server for whoever is the authoritative name server for CNN.com. And then from that authoritative name server, that name server is then going to tell you what the IP address is. And so the authoritative name server then says it's 204.66.4.1. That is then given to your computer. Your computer then goes to that particular IP address that's on the internet, and then it's able to actually access the server. And so this is the mess of basically how this works when you're dealing with internet level fully qualified domain names. You're going to go to the host file first, not going to find it there. Going to go to your local DNS server. Your local DNS server isn't going to have it. Your DNS server has primary and secondary DNS servers that it's configured to go communicate with, that are generally your ISP DNS servers. It'll communicate with that. Let's just say at this point that it's not actually cached in the ISP DNS server, though it will be. It's one of those things. It probably will be. But then from there, then your ISP DNS server is then going to communicate with the root DNS server infrastructure. That is then going to point you to the .com, the top level domain DNS infrastructure, which will then point you to the authoritative name server for that particular domain name. That authoritative name server will then actually resolve the IP address for you, and then you'll actually be able to go to whatever IP address is. So this is basically how the name resolution works when you're dealing with the full-fledged internet. So with this, I want to take a minute and just talk about caching for a second. So caching is a process that computers use essentially whenever they have to access any kind of data that they figure they're going to have to access numerous times. Instead of continuously going out to servers and going through the whole request process in order to be able to download or to get information, many times servers, computers, networking type devices will actually cache the DNS or the information that they've requested in the past, and then when they need it for a time period going into the future, they'll simply go to the local cache versus going all the way out to the network or the internet or that type of thing, right? So if you look at this and you think about, okay, your computer has to go to the host file, then local DNS server, then the ISP DNS server, then the root, then the TLD, then the authoritative name server. I mean, even for computers, right? Computers are fast. But if you're thinking every time you go to a website, it's going to have to go through this process, right? You're probably thinking that seems like a lot of waste of resources, and it is. And so that's why computers and all this kind of equipment generally cache this type of information. So on your computer, you actually have a DNS cache, and that DNS cache is simply a temporary file that contains the IP addresses and the fully qualified domain names of fully qualified domain names you've had to access recently, and so it will go to that cache first to see if it's already in the cache before it goes up to your local DNS server. Your local DNS server also probably has a cache, and so if this is a fully qualified domain name that's been used a lot in the network, it probably already has something in its cache, and so it will simply resolve from the cache, not necessarily go through this mess. Your ISP's DNS server, again, they are dealing with a tremendous number of clients, right? Tens of thousands, hundreds of thousands, millions of users hammering their DNS servers. And so they don't necessarily want to go through this process all the time. And so a lot of times they will cache DNS information. And so why this is important is when you go and you modify the DNS configurations for your domain name up in the internet, again, EliTheComputerGuy.com or SiliconDojo.com or something like that. Let's say I change the server, right? My website was on one server's IP address. Now it's on a different server's IP address. One of the reasons GoDaddy or 1&1 or basically your DNS registrar will tell you it can take up to 24 hours for that domain DNS information to propagate is because once you make that change, all of these different computers and pieces of networking equipment, they may have the information cached, and it may take a long time for those caches to expire and for the information to get dumped, so that when users are actually trying to go to your website or they're trying to go to your web service, it will actually resolve properly. So this is just kind of one of those things to just keep in mind whenever you're thinking about DNS, is there is a hell of a lot of caching that just happens naturally, and so just kind of think about this. From a troubleshooting standpoint, this is an important thing. Like if you change the IP address for a server on your network, so maybe you give a server a static IP address and then you change that IP address for some reason. Maybe you're migrating to a different platform or something like that. So server, file server was at 192.168.1.9. Now you're going to put it at 192.168.1.10. One of the things to think about is with ipconfig or the IP tools that you have on your computer, whether it's a Mac or Windows or Linux, is there is a flush DNS option. And so what flush DNS does is you do /flush DNS, and that will flush the DNS cache so that when it goes to resolve, instead of going to the DNS cache, it will then resolve, the new information, and that will hopefully get you to your server. So this is something, again, we're talking about the 2020s now, so flushing DNS shouldn't be as big a deal as it was, but this was a big deal. If you go back 10 or 15 years ago, back when I had my computer shop, a lot of times you would go in and you would screw around with DNS configurations or screw around with IP address configurations, and after you did everything properly, you did everything perfectly, it wouldn't work right. It wasn't resolving properly. And the reason is because it was initially resolving to the DNS cache. The DNS cache still had all of the old information, and so then everything went to hell. So whenever you did any modifications on the network with domain names or IP addresses on the computer you were interacting with, you always did flush DNS. That flushed the DNS cache, and then you were able to interact with the network. It is important to understand with this DNS cache, this isn't like a permanent thing. It will auto expire the information within the DNS cache. But again, when you're doing troubleshooting, or you're building a network, you're making a lot of quick modifications. And so one of the problems you can have is as you do the quick modifications, the information in the cache hasn't expired yet. And so you're using that old information. So that's just a big thing to understand here, is there is a whole bunch of caching process in all this. So just keep that in mind. So we've been talking a lot about fully qualified domain names. So we talk about fully qualified domain names, we're talking about CNN.com or FoxNews.com or file server. There is a difference between a fully qualified domain name and a URL though, right? So a fully qualified domain name is the name of the computer that you're trying to interact with. So file server might be a fully qualified domain name, or CNN.com can be a fully qualified domain name, or college .edu is a fully qualified domain name. What you are normally used to interacting with is something called URLs, right? Universal Resource Locators. And what a Universal Resource Locator looks like when you plug it into a web browser is you'll probably have something like www.cnn.com/latest.php. And so it's important to understand how this works so you kind of understand better the beginning and end of DNS, right? So DNS simply resolves the fully qualified domain name to the IP address. Once that has been resolved, right? So you have your computer here, you get the IP address for CNN.com, you go through the cloud to the server for CNN.com, right? So whatever that IP address is. So let's say CNN.com is 208.66.44.1, right? So you go to 208.66.44.1. On the server for CNN.com, you're going to have web server software. So, as an old school person like me, I think of Apache. Really old school people might think of IIS. Was it Engine X? How do you spell that? Engine X is what I guess the cool kids use nowadays. Essentially, basically, you have a server software, and that's what actually provides the web page to the browser that's trying to access it. Within this web server software is something called a vhosts file. And what that vhosts file does is it says, when anybody comes to this particular server looking for this particular domain, go to this folder, right? So if we think about the CNN, let's see, the server, this has a server that has CNN on it, right? This one server may have a folder for CNN.com's information. It may also have a folder for Fox News.com's information. I also have a folder for MSNBC.com, right? Because again, all these these news sources out there, they may hate each other when they're in front of the camera, but at the end of the day, everybody has to pay the bills. And so if a web hosting provider gives good service for a low cost, they may all go for the exact same web service provider. So you have one server here. So you have a web server, and on that web server you have the folder for CNN.com, you have the folder for FoxNews.com, and you have the folder for MSNBC.com. So on that server, you will then have something called the vhosts file, at least as far as Apache is concerned. And basically what will happen there is it'll say, okay, if somebody comes to this web server looking for CNN.com, then where you're going to go is you're going to go to var, www HTML cnn.com, and you're going to go into that folder and look for a file generally called index.html or maybe index.php, something like that. So in this folder, there will be a file called index or default. And so when somebody comes to the server looking for cnn.com, go into this folder and then basically open up the index file that's in there. If somebody is coming to foxnews.com, go to var www/html/foxnews. And then in there, it will have its own index file, and somebody will get the index file for Fox News. The same thing is true for MSNBC, right? So that's how the vhost file works. When you deal with the vhost file, though, you do have to put in some, like all of the information that you want. So you want to say, okay, if somebody just goes to plain old CNN.com, you want to put in what folder they go to if they go to CNN.com. If they go to www.cnn.com, you then want to say what folder they go to with www.cnn.com. This is something you'll notice with some people, if they don't have good administrators, sometimes www.cnn.com will work right, and sometimes if you just plug in cnn.com, that's it, it will fail out. And the reason is because they have not put a configuration within the vhost file to say what folder just simple cnn.com goes to. You can also, with this, you can plug in other stuff like other name.cnn.com, and that could point to an entirely different folder that has different informations in it, or potentially a different web application. So when you're using domain names, one of the things you need to be thinking about in the real world is making things easy for your users to understand. So if you give them a single domain name and then basically you put additional things on the front, it makes it easier for them to remember. So www.cnn.com, that will point to this particular folder. You may have like ftp.cnn.com, and you may want that to point to a different folder if people are looking for documentation or things. All right, you could have like, let's say hr.cnn.com, that will point to a folder that has an index file in it, and then that index file will simply be all of the HR documentation that you may need, right? It'll have the 1099 documentation, the W-2 documentation, maybe a sexual harassment complaint documentation. And so that way it's like, okay, if I want to go to www.cnn.com, I'll get CNN's website. If I need HR information for cnn.com, that will drop me into a different folder, and then I get these documents here. Past that, right? Okay, so we got www.cnn.com. So we have the vhost file, and the vhost file dumps you into a particular folder, and you will open up generally whatever the index file is in there. Now, if you look at www.cnn.com, and then it's /latest, let's say .php, what this is a file within this particular folder, right? So in this folder, you may have index, you may have latest, you may have, most popular, and these, let's do PHP. You know me, I like PHP. Let's say, oh, this is all PHP, right? So you may plug into your web browser, www.cnn.com /popular.php, and what this will do is this will then open that particular file within that folder. And so this isn't really part of the DNS process at this point. To be clear, this isn't really the DNS process. This is when you start dealing with web servers and that type of thing. But I think understanding this makes the DNS resolution process a lot easier, right? So the CNN.com, that's going to give you the IP address 208.44.66.1. You're then going to go to the server that's at 208.44.66.1, it will look in its vhost file for where to route www.cnn.com. That will dump you into a particular folder, and then when you open up a file in that particular folder, that is what comes after the forward slash in the URL that you're dealing with. So this is basically how this whole mess works. We will talk about this, of course, in a different class at some other point in time, but this kind of this tries to explain to you the overall process that's going on. So now that you understand how local DNS resolution works and how the internet DNS resolution works, and then basically kind of sort of how the whole web server thing works, I just want to take a minute and take a look at internet DNS records so that you have an idea of what this looks like. So this is basically the DNS records for some particular website. I just went out there, I grabbed a picture off the internet, but with this it shows you some of the different record types that are held for internet DNS. You have something called the A record, the A record, you have this, what are called C names, you have the MX record, and the important thing here, you have NS, which is the name server record. So what the A record is here is this is for TCP/IP version 4. This is the IP address that users are supposed to be directed to when they try to go to your particular domain name, right? So if we have etcg.com, right, it will have an A record, and basically this A record will say EliTheComputerGuy.com is at 208.55.66.4. So the important thing to understand about A records, these internet DNS records, is the A record is always going to point to an IP address, and that is it. You then have something called a C name. So C names are very useful because basically this is a way to give servers on the internet essentially aliases, again, to make it easy for your users to be able to access services with something that they can remember. So let's say, with EliTheComputerGuy.com, etcg.com, when you want to go to the website, you go to 208.55.66.4. But let's say I have my users, my internal employees, we have a webmail service set up for them. And so we want a name that's very easy to remember. So we want them to be able to use email.etcg.com to go to our email service, our web-based email service. This could be Gmail. For here, this is configured for GoDaddy's email service, but something like that. So with a C name, what you can do is you can actually plug in a fully qualified domain name, and essentially, more or less, when somebody plugs in the C name plus your domain name, so email.etcg.com, they will be routed to here, email.secureserver.net, what you've configured. And so then from there, they can log in, and then they can get their email services. This can be a very easy thing to do, again, for, let's say, if you have email services that you want your users to be able to access relatively easily, maybe something like Dropbox, that type of thing, basically you can create these C name records essentially to forward people to these different servers. The important thing here, though, is for these different servers, they need to have that fully qualified domain name to point the folks in the right direction. Past that, when we go down here, you will see we have the MX records. The MX records are the mail exchange records. So whenever you send email, right, email uses a protocol called SMTP, Simple Mail Transfer Protocol. So when you send an email from point A to point B, one of the things that's going to have to occur is that the service is going to have to resolve the domain name to an IP address, right? So if you send an email to eli@eliTheComputerGuy.com, in order to get to my mail server, you're going to have to resolve etcg.com to my mail server's address. And so basically what you have here with MX records is when somebody tries to send something to etcg.com, first it will go to a server called mailstore1.secureserver.net, and then after that it will go to smtp.secureserver.net. So the mail exchange exchange records. They resolve IP addresses for basic email services. Whenever you see MX records, you'll generally see up to 10 different MX records within a configuration, and essentially this is for alternates, right? If the primary server for email is not online, then it'll go to the secondary, then it'll go to third, then it'll go to fourth, it goes fifth, it goes to sixth. That's where we'll see this priority thing here. So there's a priority, there's a priority. Basically, that tells you in what order should a server try to connect to this other email server in order to try to send an email. So that's the MX records. Then finally down here, you have your name server. So the name servers, right, the authoritative name servers, these are the servers that actually give your IP address to whoever is trying to resolve your IP address. So here, ns21.domaincontrol.com, and then you have a secondary name server for ns22.domaincontrol.com. Normally, this is kind of one of those things that you do not screw with, you do not modify at all, because if you fat finger this, it's going to break everything, right? Because that's the thing, that TLD, right, the top level domain DNS servers, right, they are simply going to have this information within their database. If you plug in the wrong information here, then that wrong information will be given to the clients trying to access your server, and then it won't be able to resolve because it was given the wrong information, so everything will fail. And so these, generally, you do not change. Where you may change these is sometimes when you buy a domain name from one company, but then you set up your cloud server infrastructure with a different company, you may have to change these name servers in order for this to work properly, right? So basically, let's say you buy a domain name from GoDaddy, and then you set up a cloud infrastructure, you set up cloud servers with a 1N1. So one of the things you may have to do is you may have to change this configuration setting here to have 1N1's name servers basically being used in order to resolve the information for your particular fully qualified domain name. So these are the different records that you may see with internet based DNS. You have the A record. Essentially, that's generally for your primary server. You plug in an IP address there. You have the C names. Essentially, this is a way to give aliases in a very easy to read fashion to your users. You then have the MX records. These are mail exchange records, the records for actually being able to send and receive email. And then you have the name server records. And the name servers, these are the ones that actually do the final resolution of your domain name to an IP address. The next thing I want to take a moment to talk about is reverse DNS. So one of the things everybody should be concerned about in the modern world is security, 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 right? And so one of the issues you can have is when you have infrastructure with all of these different servers and basically all of these different configurations, one of the concerns is basically what happens if somebody can get in the middle, right? So you have your computer here, you connect to your DNS server, your DNS server doesn't have the proper information, so it goes out to the ISP's DNS server. What if somehow basically a hacker is able to route you to their own DNS servers, or they're able to spoof something like that? So instead of going to the server you're expecting to go to, they get you to go to a server that's under their control, and then they try to collect your information. This can be a very big problem, and this can actually be a problem on local area networks. That's one of the things hackers will do, right? Basically, you have your local area network that everybody is connected to. You're trying to connect to the server. They go in and they try to hack the DNS, and they try to get you to connect to their little box that they've put on your network. Possibly they put in a Raspberry Pi, something like that. They try to get you to connect to their box and then ask you for your credentials. Hopefully you're an admin account. They ask for your username and password. You plug it in. They grab your information. They then use that to actually connect to the real server, and everything goes to hell, right? And that's a question, right? How do you know that server is actually 192.168.1.2 and not 192.168.1.12? itself, right? How do you know it's resolving properly? So one of the things you can set up, especially on your local area network, is something called reverse DNS. So DNS resolves fully qualified domain names to IP addresses. Reverse DNS resolves IP addresses to fully qualified domain names. So essentially what happens is when you go down and you sit at your computer and you type in, I want to go to file server, what will happen with the DNS infrastructure is it will give you the IP address. And then one of the things, this kind of automatically happens in the background, is your computer can then ask and basically try to resolve the IP address back to a fully qualified domain name to make sure those two things actually equal out. This is a big thing with Microsoft Active Directory infrastructure. Again, one of the valuable things with Microsoft, I'm probably not supposed to say this in the modern world, but I think Microsoft is really cool for many reasons, and one of the reasons is a lot of the security things that they actually built into Active Directory. And when you're dealing with DNS and DHCP and a lot of these infrastructure type services, and this reverse DNS service can be incredibly valuable and incredibly useful for security on your network. And so all reverse DNS is simply resolving an IP address to a domain name to make sure both actually match up, and if they don't match up, then hopefully the network traffic will fail out because there's a problem there. So now let's take a moment to talk about public DNS servers, right? So public DNS servers, you will most likely hear of public DNS servers from either Google is big for the public DNS servers, or Cloudflare. Cloudflare has their own new public DNS servers out there. So one of the problems you can run into, right? So your computer goes to your DNS server, doesn't resolve. So then you go to the ISP's DNS server. Well, here's the issue. When you go out to somebody else's DNS server, this is actually a server, and they can configure this server to do whatever the hell they want. And a lot of times what they decide to do is they basically try to rip away all of your privacy, and then many times they just end up screwing with you too, essentially any way to make a dollar. So one of the things that's very important to understand with any of the server services is that everything can get logged. Everything can get logged. When you go to your ISP's DNS server, they can log your IP address. So whatever your IP address is on the external network, they can log your IP address with every single domain that you're going to, and they can use this in order to try to sell this information for advertising purposes or different things like that. Not only that, I used to have Verizon Fios. Now to be clear, Verizon Fios, the actual fiber optic internet connection, was amazing. I had it for like 10 years and it worked wonderfully for 10 years. What I didn't like was Verizon's ISP service. So when you put in their DNS servers into your DNS configuration, what would happen is if you plugged in a fully qualified domain name that wasn't quite right, they would essentially route you to Yahoo. Right? So if I was sitting there and I was a little tired or whatever, if I type in CNN.com, right, Fios would give me the right IP address. If I typed in CNN. I don't know, Cone, let's say, I was tired, I didn't realize what I was doing, right? This should fail out, right? A hard fail, as I talk about a lot, is a useful thing because you know that you screwed up. I put in CNN.com instead of CNN.com. Normally, it should just fail. That website doesn't exist. Well, you know what Verizon would do? I would then get a web page that would open up with Yahoo, with all kinds of different links to whoever the hell they thought they could sell an advertising link to get me to click on something, right? So I go to CNN.com. Instead of it failing out, I get this Yahoo page that opens up. I'm saying, what the hell is that? Why the hell does CNN open up to a Yahoo page? And then I start clicking things because I'm kind of confused about what's going on. Verizon starts making all of those pennies by making my life miserable. And sadly, that's one of the problems that we have in the modern world of business is this whole issue of companies they will not stop trying to make a penny off of you. You're already like I was spending good money. I was spending $100 a month on FiOS internet, and yet they still had to screw with me with their damn DNS servers just so they could get a couple of extra pennies out of me. So what the public DNS servers with Google or CloudFront do is since Google and CloudFront they don't actually make money from screwing around with you in this way, right? Google makes money when you can actually go and do a normal Google search and you click on a normal Google ad. Cloudflare makes money just by proving that they're actually a good networking type service, so enterprise type clients spend lots of money with them. So what they've done is they've come up with their own public DNS servers that you can use instead of your ISP's DNS server. So with Google, it's 8.8.8.8, and I think it's also 8.8.4.4. I do believe those are Google's DNS servers. Cloudflare, I think, is actually 1.1.1.1, right? So you can plug these DNS servers into the configuration for either your computer, so your individual computer that you're sitting down at, or your router, right? Your modem router that you have. You can plug in these DNS IP addresses. So instead of going to your ISP, where they're going to try to make those extra couple of pennies from you, you can go out to Google, or you can go to Cloudflare, or you can go to somebody else. There's companies like OpenDNS. There's a whole bunch of different public DNS servers you can use out there that have different services. Like so with Cloudflare and Google, they're not going to reroute you, right? That's one of the valuable things. They may be a little faster than your ISP's DNS servers. One of the things it's OpenDNS. They're actually used for security, right? So they actually have databases of nefarious websites. So if you try to go to wewillhackyou.com, basically it won't resolve, right? If you use OpenDNS, and if you're trying to go to a fully qualified domain name that they know is nefarious, they will simply fail out that name resolution versus allowing that to occur. The problem that you're going to run into, though, if I can get my thing back. There we go. The problem that you can run into, though, is do remember these public DNS servers, they have no idea what's going on in your local network, right? So one of the issues we run into is we have noobs that get really smart and they're like, I'm going to make my computer faster, and then they don't understand why they can no longer connect to the server, right? So think about it this way. You have your computer here, and obviously it has the host file on it. And then let's say you need to connect to file server. Well, if on your computer you've configured DNS to be 8.8.8.8 and 8.8.4.4, when you type in the name file server for however you're going to be trying to connect to file server, right? This is on your local area network. Your DNS, your resolution is going to go from your computer out to the cloud, out to Google's infrastructure, and then Google is going to try to resolve the name file server, right? And so that is something that it doesn't know what the hell the IP address is, because Google deals with the cloud. It doesn't deal with your local area network, and so it will fail out and people will get frustrated. This can be a major problem, especially with new people and people that are just learning about cybersecurity and all this other kind of crap, is they will reconfigure the DNS information on their local computer, and then they'll no longer be able to resolve the things on their local network, right? If you have a mail server, so let's say they have a mail client on their computer, so you guys are using Exchange or something like that on the local area network. If they futz with these DNS configurations to be public DNS servers, the public DNS servers don't have any information about your mail server, and then it's going to fail out and people are going to cry, and then you're going to have to do a lot of work for stupid reasons. So what you do with these public DNS servers is you actually put these into your router, right? Your router or your whatever DNS server you have, right? So you have your local computer here. Basically, you connect to the switch. On the switch is your router, and then this is your DNS router, and then within its configurations, you then add the public DNS servers. Why this is important is because if you have a file server on your network, your computer is then going to go to the local DNS server. So you say the local DNS server is 192.168.1.1 is mostly what it's going to be. So I'm looking for file server, go to 192.168.1.1 and get me the IP address for file server. You go to this DNS, it says, okay, it's a 192.168.1.10. That IP address is given to you, and then you're able to get to the file server. When you decide to go to cnn.com, but you plug in .con instead, then this DNS server will say, I don't have the information for this, so now we're going to go to the public DNS server, Google's DNS server, and then Google's DNS server will then try to resolve this. And therefore, you get the benefits of the speed and the security and that kind of thing, but your internal DNS infrastructure also works too. So that, again, this can be a really big problem when you start building out these networks and you're taking a look at DNS and resolution, as you have to be thinking about all of these different steps and make sure you're not shooting yourself in the foot. So there you go. Now you understand a little bit about DNS. A domain name system, domain name service, domain name server, DNS. You're resolving fully qualified domain names to IP addresses. That's really all there is to it, right? The first thing to remember is that your computer is going to go to your host file. So your host file is a text file that is actually on your computer, and that can actually be a very valuable tool for real technology professionals. Let's imagine for a second that you want to have a test web server running on your internal network, and so you want to be able to interact with it the same way that you would interact with a server if it was up on the internet. Right? One of the things that you can do is normally when you resolve to DNS, you'll resolve out to your server that's up on the internet. You can actually go into your host file, change, basically put in the domain name and the IP address. So since that's the first thing, that part of the DNS resolution, you'll pull up that information and then you'll go to your local server instead of going out to the internet. That can be very useful. For security purposes, I'm not really sure how much this is still used in like anti-malware software, but this was a big thing back in the day with anti-malware, anti-spyware software. The software essentially would go in and it would add a bunch of basically dead IP addresses for all of these different fully qualified domain names. Essentially, we will hack you.com and we like hacking.com and youbehacked.com, right? What they would do is they would simply put an IP address of 1.1.1.1, or they would put some crap IP address in there. So if you tried to resolve to an IP address or to a domain name that they knew was used by hackers or nefarious purposes, it would just fail out that resolution versus allowing that to actually happen. So the host file can be incredibly valuable. Past that, you're going to go to your local DNS server. For a lot of folks, again, in a small office, in a home office, that's probably going to be the modem router that you have that you're given to you by your ISP, and that will have the DNS information, hopefully for everybody on the local area network. You may run into a problem sometimes where some computer gets connected to the network, but it doesn't actually tell the DNS server what its domain name is. If you run into that problem, it can be a bit of a bugger. This may be because you configured a static IP address for that particular server, and maybe that's why it didn't tell the DNS server that it was there. If you're dealing with Microsoft Active Directory because of some security services, it might not auto-update the DNS table. That's just kind of one of those things just to keep in mind. Past that, essentially, if you're trying to resolve a name, if it's not on the local area network, then your local DNS server will then go and it will query whatever DNS server it has within its own configuration. This is most likely going to be your ISP's DNS server. Again, you got to look at your own ISP and you got to decide whether it's good or not. Some ISPs don't screw with their DNS, which is the way to go, the proper way to go. Other ISPs like Verizon Fios decide they need to make every extra penny, right? So anyways, you're going to either go to your ISP's DNS or you're going to go to a public DNS server such as Google or Cloudflare like to talk about, going to see if they have the DNS information that you're looking for, because again, they are going to have their own database tables and caching and all that kind of thing. If they don't have the IP address, then essentially they're going to communicate with the root server. So there's 13 quote unquote root servers. Again, more root server infrastructure. They will then point you to the top level domain servers for .com, .edu, .org, such and so forth. You're going to then go to that. So the .com TLD server service, they are then going to point you to your authoritative name server. So when you go and you buy a domain name on oneandone.com or GoDaddy.com or whatever else, basically once you buy that domain name, they're also going to control the authoritative name servers that are actually going to say the domain name to the IP address. Then that's going to resolve, give you your name, going to give you the IP address for the domain name, and everything should work properly. Past that, again, I showed you some of the internet DNS information. You have what is called the A record. The A record is going to point to an IP address, so a public internet IP address. This is essentially most likely going to be for your web server. You're going to have something called the C name record. The C name record can point to a fully qualified domain name, and this may be essentially to point people to let's say your email service. So let's say you're using Gmail as your corporate email service, so that people don't have to remember a whole bunch of different things. You can just simply have mail.elithecomputerguy.com point to, whatever the domain name is for your service on Gmail. Therefore, people don't have to remember a whole bunch of stuff. Past that, you then have your MX records. The MX records are the mail exchange records where your email servers are. You put that information in there, and then you have your name server records, your NS records, and those name server records literally point to the name servers that have the information for your DNS records. If you fucks that up, that can be a very bad thing. Past that, again, a lot of this stuff you just sit there, you play with, you configure, again, for security purposes, for speed purposes, for all that kind of stuff, you can create, you can artistically create whatever kind of DNS infrastructure you want. Just be careful with it, because again, these steps in resolution, if you screw something up, it can cause a lot of problems. Again, for your local computer, right, your local Windows computer or Mac computer or Linux computer, if you put the public DNS servers for the primary and the secondary DNS server, just realize those public DNS servers have no idea what's going on in your local area network. So when you plug in file server, it's not going to resolve because they're public DNS servers. They're not a private DNS server. And so that's one of the things is, so you put those public DNS servers into the DNS server that you have on your local area network, most likely your modem or router, so that your computer first tries to resolve to your local DNS server. Your local DNS server doesn't have the information, then it goes out to the internet. That's just kind of one of those things, to really be thinking about, because that can cause people a lot of problems. Again, that's what technology professionals get paid for, basically fixing all the problems that noobs create because they do something foolish like that. Beyond that, the final thing that I'll say too is do remember caching. So there is caching at almost every level of DNS resolution, because if all these different levels had to communicate with everybody else every single time a domain name had to be resolved, it would just require a lot of resources, right? It makes a hell of a lot more sense. You pull down the information and then you store it locally for a period of time, flush it every once in a while, but therefore you can just go to the local data store instead of going through this whole resolution process. So just remember that, right? So when you go out and you're changing your domain, the server that your domain name points to. So if I have elithecomputerguy.com, I move my virtual private server from GoDaddy to 1&1, so it has a different IP address. Just realize when I make that change, different people's computers may have cached the old IP address for a while, and so things may not work properly until everything, that those caches get flushed and they go to the server they're supposed to. If you're doing a lot of DNS modifications, an important thing is there's something called Flush DNS. Do a Google search for the operating system that you're using, but basically like IP configure whatever space / flush DNS. What that does is it flushes out that DNS cache so that you make sure you're resolving to the current DNS configurations and not something that you already have in your cache. And then finally, again, I told you about the URL, how URLs are different than simply the fully qualified domain name. So CNN.com is a fully qualified domain name. www.cnn.com is a URL. There is something called the vhost file in your web server. When you actually get routed, like using a web browser to a server, it's then going to see what website that you're trying to go to and what file you're trying to go to. So www.cnn.com can be different than cnn.com, which can be different than, whatever, latest or whatever.cnn.com or something. And based off of that, then the vhost file will direct the user that's coming in to a particular folder. Generally within that folder, you'll simply open up what is called the index file. So it's either index or default. It might be HTML, PHP, a whole bunch of other different extensions, but basically that will automatically open up to give you the web page. If you go to a different page within that website, again, latest.php, most popular.php, then it would be www.cnn.com/latest.php. And so that's the file that you're looking at within the CNN www.cnn.com website. Anyways, clear as mud. I hope all that made sense. So yeah, just another step, just another block in the whole world of networking. Again, do remember with any of this, just take some time. Watch the class. Walk away, think about it a little bit, do a little bit of research, play around with some stuff, maybe come back to this class again. I swear to you, when you're first learning this seems really, really, really complicated. And then when you're actually doing this after a year, you just don't even, you don't even think about it anymore. That's what's so hard. It's what's so hard about teaching some of these classes sometimes is it becomes so second nature. Like you just know it. But then you didn't always just know it. So trying to figure out how to explain what you just know so a new person can do it, that can be a bit difficult. But anyways, I hope I was able to make this make sense to you. So as always, I enjoyed teaching this particular class, and I look forward to seeing you in the next one.